Hello students, today we are going to learn some more questions which is asked from the board by NCERT. Okay, now come on, let us go. In the following pairs of the halogen compound, which would undergo SN2 mechanism and why? Generally, comparison and the difference, if you know very well, that you should know the concept mainly. If you know the concept, you can crack out very easily. First and foremost, I would like to give all those points to be noted in SN2 mechanism. In that SN2 mechanism, reactivity series, the first one, methyl group, it is greater than primary, secondary, tertiary. Then the second one, it is a bimolecular reaction. Though it is a bimolecular reaction, nucleophile should be more stronger and it has a transformation state, and then it is what it is Walden inversion, inversion of configuration. Those points and all, it's very important to note down from SN2 mechanism. Come on, let us go. In this compound, it is attached with the CH2Cl and this is directly attached with the cyclo compound. Now, which will undergo SN2 mechanism and why? Of course, 100% this will go. And why? This primary CH2Cl primary position is there, so 100% this will go faster than this. Hope you're clear with that. Okay, let us go for the second one. The same thing only, it is attached with iodide and this is attached with chloride, which will undergo very fast SN2 mechanism. Of course, 100% iodide formation only will undergo very fast. Why? Atomic size iodine, it is bigger size, so automatically it goes away due to the nucleophile attack. So that this reaction, it's very faster. And this one, suppose such kind of formation here, bond line structure, you know very well, grade 11 you have learned to bond line structure. Now this is connected, each point it has connected with carbon, so this carbon connected with here CH3, here CH3, that means here steric hindrance is there, tertiary. But whereas here also it is there, but this point which is connected to primary CH2. So always I told primary will be faster than tertiary according to SN2 mechanism. Now I hope you got a clear idea which will undergo very fast. Now before I could say the answer, I hope you got that idea. This will undergo very faster. Hope you're clear. Come on, let us go for some more questions. Okay, now some more questions related to this point. Okay, now, and it is very important. I usually put very important like that. Okay, now next one. As you look at that, what do you understand? Here the bond line structure, carbon connected with here CH3, CH3, CH3. That means steric hindrance is more. And here, of course, CH2 it is there Br. Now the same way here carbon connected with 2CH3 here. Say, now which will react more faster? Like little bit higher level question. Okay, of course, 100%. This one also CH2 is there. This also CH2 is there. But in among which is having more steric hindrance? This point is having more steric hindrance. But here lesser point of steric hindrance. So naturally here transformation it will be easy for that SN2 mechanism. It will be very faster. Okay, so this is like 2 methyl group it is there, but here 3 methyl group. So please look at the question as you are cracking out. Okay, hope you're clear. This is the second, this answer it is a correct. Okay, now next one. As you look at this only, which will go very faster? If you know the concept 100%, before I could say the answer, you will put the tick over here. Why? Because it is direct CH3 CH2Br, but this is tertiary. As the concept says what it is, methyl primary, secondary, tertiary. Like the tertiary will not undergo faster in SN2 mechanism because it is last, but methyl it is first. Methyl primary it is first. Hope you got a clear idea. Okay, now let us go for some more related concept, related questions. Hope you understand. Now the next question asked, among these which will be faster in SN1 mechanism? Generally, if you know the similarities, comparison, difference, if you know thoroughly the concept, you will have it more confident, and whichever question comes you will crack out very easily because you are thorough in the concept level. Next point here, in this point, according to that SN1 mechanism, what are the points to be noted? First and foremost, reactivity series. What are the reactivity series to be noted? See, tertiary, secondary, primary, and methyl. So that is the first one. Then second one, two steps mechanism. First step, formation of carbocation. The second one, attack of nucleophile. The same way here, more stability of carbocation, faster the reaction will be take over. Now in this point, as you are looking only this point, bond line structure, as you are looking that bond line structure only, steric hindrance is there. Steric hindrance, it is a tertiary. Three lines are there. So naturally, which will be faster among this or this? This is the secondary, whereas here it is a tertiary. Tertiary will be faster than the secondary. Tertiary, secondary, primary, and methyl. So 100% this will be more faster than this. Hope you're clear. The second one, this is also secondary. Yeah, this is secondary and this is primary. Now CH2Cl, whereas here CH. As you are looking at this, now which will be note down? See, as you look at this one and this one, this will be steric hindrance. Yes, of course, this is secondary only. So the secondary, it is the primary. Now which will be faster? Of course, this is the secondary will be faster because the tertiary, secondary, primary, and methyl. So naturally, among these, this will be faster. Hope you're clear with it. And this is only for SN2 mechanism. Why? Because it is primary, whereas here it is tertiary. 100% the reaction. See, read the question thoroughly, so automatically you will get the answer in the prompt way. Hope you're clear with it. Okay, now I just mentioned these questions also very, very important. Please note down. Hope you're clear with this. In this point, one more point I would like to mention here. Here, CH3 thrice CBr. So C carbon atom, it's connected directly to that Br, whereas here CH2Br. So which is having more carbocation, faster stability. So naturally this one. This is also another one more point to be noted. Hope you're clear with this. The next question asked about distinguish between. What are those points? Chlorobenzene, chlorocyclohexane. How will you distinguish? Which will answer, which will not answer, how to identify? If you know the concept thoroughly, you can identify very clearly. Come on, let us go. The first one, chlorocyclohexane. How to write chlorocyclohexane? Hexane. Chlorocyclohexane only. So that means no benzene ring will be there. So this is chlorocyclohexane. How to identify chlorocyclohexane? Combined with aqueous KOH. Okay, aqueous KOH actually it is acidified with nitric acid and we should add silver nitrate solution to check. Okay, now if we go for this reaction, what do we get? We will get what it is? Cyclohexanol. We will get what it is? Cyclohexanol. This is hexane, cyclohexane, and this is cyclohexanol and KCl. Okay, now this KCl combined with the silver nitrate solution, what do you will get it? Silver nitrate solution, automatically you will get AgCl, and the next one what it is? KNO3 and AgCl. AgCl you will get what it is? White PPT. White PPT, and from that we can identify what it is? Chlorocyclohexane. Whereas this one, chlorobenzene. Chlorobenzene. This is chlorobenzene. Do not undergo with hydrolysis of aqueous KOH. So here no reaction takes place. Whereas here you are getting white PPT. How do you get white PPT? How to differentiate these two? Chlorocyclohexane reacts with aqueous KOH. That reacts aqueous KOH. Aqueous KOH is acidified with nitric acid and along you are adding what it is, silver nitrate. So before adding that silver nitrate, first and foremost you should get KCl, then only you can add silver nitrate. Okay, when it is reacting with KOH, you are getting what it is, cyclohexanol, that is alcohol formation. Then next one. So alcohol formation means what it is? Elimination or substitution. I hope you are clear with that substitution elimination reaction. Please recall those points. Next one, KCl and AgNO3. Then you are getting white precipitate. White precipitate is identifying what it is, chlorocyclohexane, whereas here there is no reaction because it does not undergo hydrolysis point. Hope you're clear with that. Okay, next one more point for one more question for the distinguish between. The next question from distinguish between benzyl chloride and chlorobenzene. Benzyl chloride, how to write that benzyl chloride? C6H5 CH2Cl. Benzyl CH2Cl. How to identify? The same concept, aqueous KOH. Aqueous KOH. Before reacting with aqueous KOH, it has to acidified with nitric acid. Yes, you are getting what it is? Alcoholic formation. What is that alcoholic formation here? CH2OH, benzyl alcohol. What do we get? Benzyl alcohol plus KCl. This KCl reacts with AgNO3. What you will get it here? AgCl. AgCl you will get what it is? White PPT. Then KNO3. Here white PPT. White PPT. Yes. From that we can identify. Here this you will get white PPT when it reacts. Benzyl chloride reacts with KOH. Whereas chlorobenzene actually it is a stubborn point. Here chlorobenzene, anyway you can put it here also. Chlorobenzene do not react with aqueous KOH, do not go undergo with the hydrolysis point. Okay, if you heat also, so no reaction. A reaction, it's very stubborn, do not undergo hydrolysis with aqueous KOH. Hope you're clear with these 2 points, benzyl chloride and chlorobenzene. Thorough? Come on, let us go for another one more distinguished question. Okay, now one more question that distinguish between ethyl chloride and vinyl chloride. Now let us go for that. And I wanted to mention here why chlorobenzene do not undergo KOH at this end of this point. Okay, now come to this point. Ethyl chloride and vinyl chloride. Okay, same concept only. What is that concept? Aqueous KOH only. Yes, ethyl chloride, what it is? CH3, CH2, Cl combined with aqueous KOH. It is acidified with HNO3. Yes, got it. Okay, so what you will get? Ethanol only. CH3, CH2OH. Aqueous KOH. What reaction? Please mention in my comment box. Aqueous KOH, alcoholic KOH. Hope you're clear with it. Yes, this. Then you will get what it is? KCl. This KCl combined with AgNO3, what you will get it? Yes, white precipitate I can hear. AgCl. AgCl, it is what it is? White PPT. White PPT. And you will get what it is? KNO3. Whereas vinyl chloride. Vinyl chloride, what is the formula? CH2 double bond CHCl combined with aqueous KOH. Here, no reaction. No reaction. Okay, now I wanted to mention here chlorobenzene. Chlorobenzene do not undergo hydrolysis of KOH. Do not undergo with hydrolysis of aqueous KOH. I mentioned those 2 questions also the same. And here also vinyl. I wanted to mention the main point for that, why it does not undergo that. See, benzene, chlorobenzene also, here what it is, the double bond, see here, this double bond which is connected, that what it is, benzene which is connected with the chlorine, and here also double bond it is there. So the carbon which is connected to that chlorine, which is partial double bond, due to that resonance, it will not undergo with the hydrolysis. Yes, it is a resonance. Due to that resonance point, it will not do not undergo with that hydrolysis. See, double bond it is there. Here also double bond. So carbon connected with chlorine. That means it is having a partial double bond resonance. Due to that, it do not undergo hydrolysis. Then you can ask one more question. How when it will go for hydrolysis? Yes, phenol along with the phenol, higher temperature 623 Kelvin and 300 atmosphere, so automatically it will undergo hydrolysis with phenol. Hope you're clear with it. Thanks for watching, and some more questions I would like to put it here. I put some more questions. The same concept only we are getting, that which will undergo aqueous KOH, hydrolyzed with aqueous KOH, which do not undergo with aqueous KOH. I hope you got the concept very well. Now you can do it on your own. Test yourself question and give that comment in that comment box. Answer I want. Okay. Now that for here, what is the third, fourth one? Chlorobenzene and N-hexyl chloride. Now, which will undergo aqueous KOH? Which will undergo that hydrolyzed with aqueous KOH? Which do not undergo? Yes, of course, this do not undergo. And chloroethane and bromoethane. Okay, now next one, 3-bromopropene. Here, propene and bromopropane. 1-bromopropane. Hope you got a clear idea. This also I just mentioned in a clue. Hope you're clear. Thanks for watching. Here, one more point I wanted to mention, chloroethane and bromoethane. Chloroethane, when it undergoes with aqueous KOH, hydrolyzed with KOH, what you will get white PPT, whereas here bromide, you will get yellow PPT. Please remember all these questions you try to solve. You see, one thing I would like to tell you, practice, try until you get success. Swami Vivekananda told, practice, then you will get perfect and you will get the confident also. Hope. Thanks for watching.